Hello everyone! Welcome to another episode of Deep Dive Knowledge Talk. Can you explain the concept of self-rewarding language models, SRLMs, and how they generate their own rewards during training?
Self-rewarding language models, SRLMs, are a type of language model that not only generate responses for given prompts, but also have the ability to generate and evaluate new instruction following examples to add to their own training set. The concept of SRLMs involves two main steps. 1. Self-instruction creation. In this step, the SRLM generates candidate responses for newly created prompts. These prompts are created by the model itself. 2. Instruction following training. In this step, preference pairs are selected from the generated data. These preference pairs represent pairs of candidate responses that are compared and ranked based on their quality. The SRLM uses a technique called direct preference optimization, DPO, to train itself based on these preference pairs. During training, the SRLM uses a technique called LM as a judge, prompting to predict and assign rewards to the candidate responses it generates. This means that the model acts as its own judge and evaluates the quality of its own responses. The rewards assigned to the candidate responses serve as a training signal for the SRLM to improve its performance. By generating their own rewards, SRLMs are able to overcome the limitations of training reward models from human preferences, which may be bottlenecked by human performance level. This self-rewarding mechanism allows SRLMs to continuously improve their instruction following ability and reward modeling ability throughout the training process.
That's fascinating. So by using the LM as a judge prompting technique, the SRLMs are able to not only generate their own candidate responses, but also evaluate and rank them based on their quality. This self-rewarding mechanism seems to address the limitations of training models solely on human-authored data. Could you explain a bit more about the direct preference optimization, DPO, technique used in the instruction following training of SRLMs? How does it contribute to the model's improvement?
The direct preference optimization, DPO technique, used in the instruction following training of SRLMs, contributes to the model's improvement by fine-tuning the model based on human preferences. DPO avoids training a reward model and instead directly trains the language model, LLM, using human preferences. It achieves this by iteratively comparing different generated responses and selecting the one preferred by humans as the winning response. The winning response is then used to update and improve the LM. This iterative training approach allows the model to learn from its mistakes and gradually refine its responses to align more closely with human preferences. By continuously comparing responses and selecting the most preferred ones, the model can learn to generate more accurate and contextually appropriate instructions. DPO helps in improving the model's performance by leveraging human feedback to guide the training process. It allows the model to adapt and learn from real-world examples, making it more capable of generating high-quality instructions. By directly optimizing the LM using human preferences, DPO helps in fine-tuning the model and improving its overall performance in instruction following tasks.
Thank you for the explanation. It's interesting how DPO avoids the need for a separate reward model and instead directly trains the language model based on human preferences. This iterative approach of comparing and selecting the most preferred responses allows the model to learn from its mistakes and gradually improve its performance in generating accurate and contextually appropriate instructions. In the study, the authors mention that fine-tuning Llama 270B on 3 iterations of their approach yielded a model that outperformed many existing systems on the AlpaCaval 2 leaderboard. Could you provide more details about the AlpaCaval 2 leaderboard and what it measures? How does the performance of the SRLMs compare to other systems on this leaderboard?
The performance of the self-rewarding language models, SRLMs, on the AlpaCaval 2 leaderboard is compared to other systems. The leaderboard measures the win rates of the models against the GPT-4 Turbo baseline model. It evaluates the models based on their performance in generating responses to prompts, and the win rate indicates how often the SRLMs outperform the baseline model. This leaderboard format allows for a comprehensive comparison of different models' performance in generating high-quality responses. According to the report, the SRLMs show improved win rates over the baseline model as the iterations progress, indicating better performance in generating responses.
Thank you for clarifying the purpose and measurement of the Alpacaval 2 leaderboard. It's impressive to see that the self-rewarding language models, SRLMs, outperformed the GPT-4 Turbo baseline model in terms of win rates as the iterations progressed. This suggests that the SRLMs were able to generate higher quality responses to prompts compared to the baseline model. In the context of the study, can you explain the significance of the SRLM's ability to continually improve in both instruction following and reward modeling? How does this contribute to the goal of achieving superhuman agents?
The significance of the self-rewarding language models, SRLMs, ability to continuously improve in both instruction following and reward modeling lies in their potential to achieve superhuman agents. In the study, it is argued that to create agents that surpass human performance, we need to provide them with superhuman feedback during training. Traditionally, reward models for language models are trained using human preferences. However, this approach has limitations. Firstly, it is bottlenecked by human performance because the reward models are only as good as the humans providing the preferences. Secondly, these reward models are separate from the language model and cannot learn to improve during training. The SRLMs address these limitations by training the language model itself to provide its own rewards. This is done through a process called LLM as a judge prompting. During Iterative DPO training, the SRLMs not only improve their instruction following ability, but also develop the capability to generate high-quality rewards for themselves. By continuously improving in both instruction following and reward modeling, the SRLMs are able to enhance their performance beyond what is achievable by traditional methods. This contributes to the goal of achieving superhuman agents, as they are trained to provide feedback that goes beyond the limitations of human performance, leading to models that can surpass human capabilities.
Thank you for explaining the significance of the SRLM's ability to continually improve in both instruction following and reward modeling. It's fascinating how the SRLMs address the limitations of traditional methods by training the language model itself to provide its own rewards. This approach not only enhances the model's instruction following ability, but also allows it to generate high-quality rewards for its own training. By surpassing the limitations of human performance and continuously improving in these aspects, the SRLMs have the potential to achieve superhuman agents. This opens up possibilities for developing models that can outperform existing systems and push the boundaries of what is currently achievable in language generation tasks. It's an exciting prospect for the future development of language models.